Integers are the set of whole numbers, both positive and negative. Adding and subtracting positive integers is fairly straightforward. Something like 2 plus 3 equals 5. We can think of this as just moving to the right on the number line. Subtracting, something like 4 minus 2 equals 2, is simply moving to the left on the number line. This is useful when we get into adding and subtracting negative integers. So if we're looking at something like 3 plus negative 5, that's equal to negative 2. So it's a little bit like moving to the left on the number line. And subtracting, let's say something like negative 3 minus negative 4, that's equal to positive 1. So we've moved to the right on the number line. Another way to think about it is that adding a negative is the same as subtracting a positive. So instead of 3 plus negative 5, we could just think of that as 3 minus positive 5 equal to negative 2. And instead of negative 3 minus negative 4, we can just think of that as negative 3 plus positive 4, and that equals 1. Now, multiplying and dividing integers is, for the most part, pretty straightforward. My suggestion is ignore the signs altogether and just worry about multiplying or dividing the two positive integers, and then afterwards figure out what the sign of the product or the quotient should be. So for example, if you have negative 8 times negative 5, ignore the negatives, just say 8 times 5 is 40, and then decide whether that product should be positive or negative. Now, the rule is that if you have a positive times a negative, the product is negative. If you have a negative times a negative, the product is positive. And of course, if you have a positive times a positive, the product is positive. We can do the same thing with division. Let's say we have negative 35, and we're dividing that by 7. And I've used a division symbol here, but you can also think of this as a fraction. I'll write that in a second. So 35 divided by 7 is just 5. This is a negative divided by a positive, so the quotient should be negative. So the quotient there is negative 5. So again, if we have a positive divided by a negative, or vice versa, negative divided by a positive, the quotient is negative. And if we have a negative divided by a negative, then the quotient is positive. So negative 35 divided by 7, as I said, you can think of that as a fraction. So negative 35 over 7, same thing, just negative 5. Now, absolute value is something you may not be as familiar with. You can think of absolute value as simply the distance from 0 on the number line. There's a special symbol that goes along with absolute value, and it's a pair of vertical bars. So when you see something like this, you read that as the absolute value of 4, and you just think to yourself, well, how far is 4 from 0 on the number line? And it's obviously a distance of 4. And same goes with negatives. Absolute value of negative 3. How far is negative 3 from 0 on the number line? It's a distance of 3. And how far is 0 itself from 0? No distance at all, so 0. So one way to think about absolute value is it just makes everything positive. It strips off any signs if they are there. This seems pretty straightforward and pretty basic, and it is when you're dealing with integers. It gets a little trickier when the thing inside the absolute value bars is algebraic, and we might see that a little bit later.